Alright, this is a video for sample surveys. So hopefully you have the note sheet that I passed out to so you can follow along with this. And the note sheet should say the top sample survey notes. Alright, the first thing we'll talk about is a census real quick. Now remember, we're not going to spend a whole video on a census because the census is very simple. Survey everybody. Everybody's included. Obviously, we talked in the previous video about how it would be great if it's feasible, and it certainly could be in some situations where your population is small, but for the most part, it's difficult to do. Anyway, so sample surveys, the first we're going to talk about is when you're doing a sample, what is a sampling method? Okay, what is a sampling method? And a sampling method is simply the method that you choose to choose your sample. Okay, so the sampling method is how are you going to choose your sample? So it's actually what you're going to do. Okay, how are you going to get a sample? Okay, that's the sampling method. Every good sampling method must incorporate what? And hopefully you should know this. Must incorporate. And I'm about to write it. I'm going to write it in a different color so it stands out. Must incorporate randomness. Randomness. So every good sampling method must incorporate randomness, meaning how you're going to choose your subjects for your sample needs to be done randomly in some way, shape, or form that we're going to learn about shortly here. The next question on your sheets would be, what must a sample do in order to be meaningful or useful? A sample must, and we've said this before, represent the population to be meaningful. If you, population, sorry for a little misspelling there. If you plan on generalizing or inferring your results from your sample to your population, the sample must represent accurately that population. Okay? So now we're going to talk about 5 good ways to collect a sample. 5 good ways to collect a sample. So let's scroll down a little bit here. The first good way, and I'm going to emphasize good way, the first, because all these are good ways. The first good way to select a sample is known as a simple random sample. Now, in the world of math, we usually are pretty lazy, so we like to find ways to abbreviate everything. So we call this an SRS, a simple random sample. And the definition of a simple random sample is very, very important to understand. Every possible sample of size n must have an equal chance at being chosen. Now let's talk about this for a minute. A lot of students misinterpret this definition and they think that every person needs to have an equal chance of being chosen. And that is not true. That is true with this idea that every possible sample of size n must have an equal chance of being chosen. So let's just say that my population is 1,000 students at John Smith High School. Okay? Then I want to choose a sample of 50 of them. Okay? And n is your sample size. So if I want to choose 50 students from a population of 1,000, every possible group of 50 students must have a chance of being chosen. Every possible group. So even a group that would, oddly enough, be 50 seniors, that group needs to have a chance of being selected. The group that would have 10 seniors, 10 juniors, 10 sophomores, 20 freshmen must have a chance to be selected. Every group that you could think of that has 50 students in it must have a chance at being selected from the population. That's what makes a simple random sample. This is the most accurate technique to do this, would be to give everybody a number Everybody in the population gets a number, so it'd be 000 through 999. That'd be your 1,000 people, right? And you're going to randomly use a random number table or a random function on a calculator to generate the 50 people being chosen. So if I asked you to describe how you would run a simple random sample, you would say everybody's going to get a number 00 through 999, and I would use a random number table or a random calculator function to select the first 50 people at random. And I'd need 50 different people, so I would ignore repeats. That is how you would do that. If your population was only 23 people, very small population, and you want to select 5 of them, then everybody gets a number 1 through 23. Number 00 and 24 to 99 would be ignored. I'm going to let a calculator or a random number table generate the first 5 numbers that come up. Ignoring repeats will be involved in my sample. Something along those lines. Doing this is the most efficient way at getting a very good random sample. So that's the definition of a simple random sample. Okay. The second good method at selecting a sample is known as a systematic sample. Systematic sample. And a systematic sample is very easy to understand. What you're going to do is you're going to systematically choose your sample by selecting every nth person. So let's say that I want to get a sample of students at Twinsburg High School. I'm going to stand at the door and I'm going to select every third person that walks into the door. Or I'm going to select every 10th person that walks into the door. Or I'm going to get a list of every student in the high school, because if you think about it, if I stand outside the front door, what if you come in another door? That would be leaving you out. Or what if you're sick that day? Then that would be leaving you out. So the better way would probably to get a list of every student in Twinsburg High School and to just, put that list into a random order and select every 4th person on the list. So that would be systematic. Some systematic way. A little bit easier sometimes to do that, but it certainly would generate a random sample. Okay. The third method to select a good sample would be what we call a stratified sample. Now, the point of a stratified sample is can help get a good representative mix. Now, what we do in a stratified sample is we first put population into similar groups. Now, that means that if I'm going to divide the population into groups, the people in that group have something in common. Group members have something in common. And that could be maybe all the people in one group are going to be girls. All the people in another group are going to be boys. It could be as simple as having 2 groups. Or it could be, think of the population of the United States. I could simply put you into groups based on the state you live in. So I'd have 50 groups based on the states you live in. If it was Twinsburg High School, I could put you into groups of the freshmen, the sophomores, the juniors, and the seniors. So we say the groups have something in common, and that means they are homogeneous. So we're looking for homogeneous groups. Homogeneous meaning the same. The groups have something in common. I could do by ethnicity. I could put the African Americans into a group, the Caucasians into a group, Mexicans into a group, Alaskan, or Eskimo into a group. I'm just trying to think of different ethnicities, but whatever. You could put based into ethnicities, okay? But obviously you want to put them into groups that have something of importance, okay? If you're interested in how people are going to vote for the next presidential election, putting you into groups based on your hair color. All the brown hair go into the group, all the black hair go into the group, all the blonde hair go into the group, all the redheads go into the group. That would be a homogeneous groups. That would be stratifying, but I don't know if that would have any impact on what we're looking at. Now, if you were doing a sample and you were interested in something about hair care products, well, then certainly doing that type of grouping would be necessary. So anyway, after you have these groups, the second thing you do is randomly choose X amount of people from each group. And what this would do is this would guarantee that you would get some African Americans, some Caucasians, some Mexicans, some Spanish. It would guarantee that you get some people from Rhode Island, some people from Ohio, some people from Wyoming, some people from Minnesota. It would guarantee that you get some blondes, some browns, some black hair girls, some redhead girls. It would guarantee that. Okay, so that's the point of stratifying. So first you put people into groups based on something that is homogeneous, something that they have in common within the groups. Or you can even do two groups, like I said, boys, girls. Okay, and then you're going to choose some from each group. How are you going to do that choosing? Randomly, because like we said earlier, every good sampling method does incorporate randomness. The fourth technique is a cluster sample. And in a cluster sample, the first thing we do is separate into groups, but groups are heterogeneous. I hope I spelled that right. I think I did. I'm not sure. I think so. Anyway, in a heterogeneous means the groups are a mix. So groups are mixed up. Meaning that in each group, I have a mix of all different kinds of people. Groups are mixed up. So if I was going to do this with the U.S. population, each group would have a mix of people from every state. Each group would have a mix of all different hair colors. Each group would have a mix of boys and girls. Each group would have a mix of ages. Each group would have a mix of races. Each group would have a mix of ethnicities. So the groups are heterogeneous, meaning the people in that group are different. And then I'm going to randomly, okay, so let me put this down. This would be second, I would randomly choose X amount of groups. X amount of groups. And survey everyone in those groups. So obviously a lot of students get cluster and stratified mixed up. Stratify. The groups in each group is homogeneous. They have something in common, and then you take a couple from every group. Cluster, your groups are heterogeneous, meaning they're mixed up, and you only take a few groups. You don't take one from every group. You take 1, 2, or 3 groups, because when you choose that group, they're already mixed up. So you get a nice mix of everything, hence it would represent the population. So hopefully that would make sense to you. The last method, number 5, is what we call, and we're going to probably talk the least about this one, but it's called a multi-stage sample. And here you basically would do two different things. Okay, so you're going to do multiple things. So this refers to a procedure involving 2 or more steps, each of which can involve any of the various sampling techniques. Okay, so maybe you do a procedure. First off, I'm going to mention this a lot. The Gallup organization, the Gallup, Gallup, is an organization that runs samples for people. So if you're a company that's interested in doing a sample and you don't feel like doing it on your own, you would hire the Gallup organization to do it for you. So maybe they follow a procedure in which nationwide locations are randomly selected. The neighborhoods are randomly selected in each of those locations. And then finally, households are randomly selected in each of those neighborhoods. So they're going to randomly choose 5 states and then randomly choose 10 cities in those 5 states, and then randomly choose 20 households in each of those cities. something along those lines. That's a multi-stage process. Okay, so I don't want talk too much about that because it should make a decent amount of sense. All right, next I want to talk about the two bad methods. The two bad methods, and these methods are bad because there is no randomness. Okay, so these are two bad methods. The first one is called a volunteer sample. In a volunteer sample, you simply allow volunteers to make up your sample. You don't choose. There's no randomness involved. You just say, hey, I need some volunteers for a sample. Who wants to step up? Major problem with that is usually people that feel strongly one way or the other about a survey question are the people that would volunteer. Also, it just creates a lot of bias. You want to avoid it at all costs. The second type is what we call a convenience sample. Convenience sample, and convenience is one of those words I always misspell, so I hope I spelled it right. In a convenience sample, maybe I want to get a sample of kids at Twinsburg High School, but you know what? I'm just going to use the 30 kids in my classroom third block because they're just in my classroom right now. It's easy for me to get to them. Or if I want to take a sample of 5 students in my third block class, I'm just going to take the first 5 people in the front row because it's convenient for me to choose them. I didn't incorporate any type of randomness. It was convenient for me to go ahead and grab those 5 people. So that would be a convenience sample. Or again, I need a sample of 5 people, so I go to the mall and just choose the first 5 people that come out of the door. Well, obviously that can be very biased because if you go during the middle of a school day, you're going to get probably elderly people. You're not going to get a whole lot of or any younger students because they don't go to the mall. They should be in school during school day and so forth. So volunteer and convenience samples are two samples that do not incorporate any type of randomness. Okay, now the next thing I want to talk about in our notes is types of bias. Okay, there are several types of bias. In fact, there should be 7 different types of bias listed there, and we're going to talk about them all right now. By the way, what is bias? What is bias? I guess we should probably define that word. B-I-A-S. Bias is the tendency to favor the selection of certain members of a population. So bias is something that you're doing is favoring a certain group of people, making it not random, obviously. Okay. The first type of bias we have is called non-response bias. And let me read you real quick here about non-response bias. This occurs when people selected just don't respond. So maybe you accurately select 20 random people from all Twinsburg high school students, and 3 of them just don't respond. They just never show up for your sample. They don't offer their opinions. They just don't respond. Well, that would obviously be an issue. Or maybe you mail out questionnaires. So you're going to randomly select 100 residents of Twinsburg High School and you mail out questionnaires to them, and 5 of them just don't send the questionnaires back. That's going to be non-response bias. Non-response bias is the bias that results when respondents differ in meaningful ways than non-respondents. That's why non-response bias is an issue, because those that do respond may differ in an important way from those that do not respond. That's why it's a problem. Some people might say, well, who cares if people don't respond? Just ask 5 other people. That's not the point. The point is the 5 people that didn't respond might differ in an important way from those that did respond. How can you attempt to eliminate non-response bias? Is oftentimes an AP question. Have some type of follow-up procedure. So if you mail out 100 questionnaires and 5 people don't respond, go to their house and ring their doorbell and try to get a response face-to-face. If that doesn't work, keep calling them every day or go to their house every day. The point is to eliminate non-response bias, you have to get a hold of them somehow or another. The second type of bias is selection bias. And selection bias is in the way that you're selecting them, whether it's unintentionally or intentionally, under or over represents the population. So if something you do underrepresents the population or over represents the population, then that's selection bias. So selection bias is when there's something wrong with your selection procedure that creates bias. Okay, the third one is what we call size bias, and this is probably the least often that we talk about, but it is important to mention. For example, if you need to choose one of the states of the United States, and you say, I'm just going to throw a dart at a dartboard that's made up of a map of the United States, that would be size bias because Texas and Alaska are bigger states, hence they would have a bigger chance of that dart landing on them, where Rhode Island or Connecticut or a small state would not, because they're small. It'd be harder to hit that with your dart. At the same time, if I put all of your names into a bag and one of you puts your name on a huge piece of cardboard and everybody else puts it on a normal piece of paper, that large piece of cardboard might be easier for me to pick, creating size bias. The fourth method is called undercoverage. Undercoverage bias. And undercoverage bias happens when an inadequate representation of the population is sampled. So some groups completely get undercovered. A famous example of this is if you just say, I'm going to open up the phone book and randomly select 20 people from Twinsburg that are in the phone book, because I have a list of people in the phone book from Twinsburg. Well, the problem with that is what if you don't have a phone? You were purposely undercovered. You never had a chance to be selected because you're not in the phone book. That wouldn't be fair. If I'm a member, if I'm a resident of Twinsburg, I should have a chance to be selected. And if you're using a phone book, I don't have a phone number, then that means I'm never going to be selected. That would be undercoverage bias. Convenience samples in themselves would be an example of this. A convenience sample would completely undercover a group of people, like the people in the back row. Yeah, it's convenient just to choose the front, so the back row never had undercoverage. Okay. The fifth method of bias is called voluntary response bias. And voluntary response bias is when you use volunteers. If you have a sample simply based on volunteers, then that's going to be a problem. So if you have a sample, if your survey deals with abortion is a controversial issue. So when you just ask for volunteers, you're going to get people that feel really strongly for abortion or really strongly against abortion. And you never hear from the people in the middle that might be important to hear from. So that kind of goes back to non-response bias. If you ask for volunteers, some people are not responding, hence the opinions of them are what's meaningful. So a lot of these biases overlap. A lot of them kind of incorporate other ones. Okay. Doing online surveys. Okay. If you do an online survey, the only types of people that would actually do that online survey, are people that have computers, hence undercoverage bias, because if you don't have a computer, you never got covered. And the other idea there is usually people that fill out those kind of surveys are people that feel really strong one way or the other, and those aren't necessarily the people we want to hear from. Number 6 would be response bias. And response bias, I actually want to spend a little bit more time talking about real quick, because response bias, so I'm going to make a whole little separate thing here. Response bias means something about the way you are proposing the question makes your response go one way or the other. Okay? So there's also another kind of, I'm just going to give you this, that's the 6th. The 7th type is called wording bias, because these kind of things actually go together. Like I said, there's some overlap here. If the question itself is worded in a way or given in a way that makes you give an inaccurate answer, that's response or wording bias. For example, if I give a question that says, do you smoke marijuana? Well, you might not want to admit to your teacher that you smoke marijuana, so you're going to say, no, I don't smoke marijuana. That would be response bias. You purposely lied because of the question itself or because of who was asking. Now, if a friend asked you that question, you might be more willing to give the right answer. So how could you cover up for that? I could say as a teacher, okay, you're going to write on a piece of paper. You do not have to put your name on it. You could but make up a different handwriting so I can't check your handwriting, whatever. And that way you can give me a response that would be more truthful. It also deals with something we call social desirability. It's not desirable to smoke marijuana, or it shouldn't be at least. And people might give an answer differently if they're asked that way. So it actually could be the person themselves. Like if the dentist asks you, do you floss? I mean, every time the dentist asks me if I floss, I say yes. Now that's an obvious lie. I don't floss all the time. But if my friend asked me, I would say, no, I don't really floss all the time. So sometimes it's the person asking that could cause that bias, or the wording of the question. So if I say, this war in Iraq is costing the U.S. millions and trillions and billions of dollars, how do you feel about it? You might be like, oh, yeah, it is costing a lot of money. I don't want to say that I'm for it, because if I say I'm for it, then it's going to sound like I'm for wasting money. So you don't want any kind of leading questions. Okay, if there's some type of a leading question or leading phrase into the question, that would create a wording bias. So you want your questions to be short and to the point, and you don't want to have any type of leading words that are going to emphasize, like if you say, hey, flossing your teeth is really good, it could help save your teeth and make your teeth whiter and cleaner and your breath fresher. Do you floss your teeth? You, because of all that opening phrasing, you might say, oh yeah, no, I'm for it. Yeah, I floss my teeth, whatever. So those are the different types of biases. So it's really important to understand response bias is the idea that the response that I'm going to get is biased because of the way I'm asking the question, or because of who's asking the question, or because something about the question itself makes you want to lie. Okay? All right, there's one more thing I want to talk about, and that is sampling error. And there's a couple questions on your sheet about sampling error. And the first is, what is sampling error? Sampling error is the natural occurring variability from sample to sample. Meaning, if I was trying to do a sample and I was interested in the proportion of kids that wear seatbelts, if I asked 100 kids, I might get a proportion, a p-hat, of 72% of kids wear their seatbelt. If I went ahead and got another sample of 100 kids, I might see 71%. If I went and got another sample, I might see 80%. If I got another sample of 100 kids, I might see 63%. The idea that all samples are going to be different, very rarely are two samples exactly the same, that idea is called sampling error. It's the natural variation, the natural difference from sample to sample. Sampling error. Is sampling error bad? No, not at all. When does sampling error occur? All the time. There's always going to be a difference between samples. If every person in the class did their own sample of how many kids wear a seatbelt, we would all potentially get different answers. Sampling error is simply the variation of those samples. Okay? When does sampling error occur? We said it occurs all the time. Can you get rid of sampling error? No. There's no way you can get rid of sampling error. It is the inherent or natural variation amongst different samples. Okay? It's never going to get rid of it. There's nothing bad about sampling error. We say error. I wish we didn't use that word error, because it's not necessarily an error. It's not a bad thing. Okay? All right. And the last thing we want to take a look at is this example right here. An auto analyst is conducting a satisfaction survey sampling from a list of 10,000 new car buyers. The list includes 2,500 Ford buyers, 2,500 GM buyers, 2,500 Honda buyers, and 2,500 Toyota buyers. The analyst selects a sample of 400 car buyers by randomly sampling 100 buyers of each brand. So there's two questions I want to ask. What type of sample is this? This is a stratified sample. Think about it. I separated the 10,000 car owners into the different types. So these people all have something in common. They own Fords. These people all own GM. These people all own Hondas. These people all own Toyotas. So they're separated into groups that are homogeneous. Each group has something in common. And then I selected 400 people from each group. Oh, I take that back. I sampled 100 buyers from each group to get 400. So 100 Fords, 100 GM, 100 Honda, 100 Toyota. That's stratifying. Why is it not simple random sample? Because the definition of a simple random sample says every single group of 400 car buyers needed to have a chance to be selected. Now I want you to think about the group of 400 Ford buyers. All 400 people chosen were Ford buyers. Under the current setup of this problem, that group was never ever had a chance to be selected because I was purposely doing 100 from each type of car. So that makes it stratified, not simple random sample, because simple random sample, every possible group had to be selected. Or think of the group of 200 Ford buyers, 200 Honda buyers. Think of that sample. Under the current situation of how this problem is set up, that group never had a chance. All right, love you guys to death. Sorry that the video is a half an hour long here, but it's a really good video. You do have all weekend to watch it, so please watch it. Get the notes taken. Apologize for the length of it, but it's going to pay off in the long run. All right, have a good weekend.